Hello students, this is week 11 from Math 135, and this week we're going to start to discuss inferential statistics, which is the process of generalizing information obtained from a sample to a population. We will study two areas of inferential statistics. The first one is the estimation. Sample data are used to estimate the value of a known parameter, such as the population mean or the population proportion. And the second thing we're going to discuss is the hypothesis testing. For this week, we're going to focus on estimating a population proportion and estimating a population mean from the sample mean and from the sample proportion. Our objectives for this week are to obtain a point estimate for the population proportion, to construct and interpret a confidence interval for the population proportion, to determine the sample size necessary for estimating a population proportion within a specified margin of error. To estimate a population proportion, we need a point estimate. A point estimate is the value of statistic that estimates the value of a parameter. For example, to estimate the population proportion, you will need to use the sample proportion, which is p hat. P hat is equal to x divided by n, where x is the number of individuals in the sample with a specified characteristic, and n is the sample size. Let's look at this example to see how we're going to use or how we're going to calculate a point estimate for the population proportion, which is the sample proportion. In July of 2008, a Colorado University poll asked 1,783 registered voters nationwide whether they favored or opposed the death penalty for persons convicted of murder. 1,123 were in favor. We want to obtain a point estimate for the proportion of registered voters nationwide who are in favor of the death penalty for persons convicted of murder. So what we're going to do, we're going to say a good estimation for the population proportion is going to be the sample proportion, and that is equal to p hat. P hat is basically how many people are in favor of the death penalty out of the sample that you chose, which is 1,123, divided by the sample size that we chose, which is 1,783. In this case, p hat or the sample proportion is going to be 0.63 or 63%. Based on the point estimate of example number 1, we conclude that more than the majority of the United States registered voters are in favor of death penalty for persons convicted of murder. Or is it possible that the actually less than the majority, which is less than 50% of registered voters nationwide, are in favor of the death penalty for persons convicted of murder? After all, statistics such as the sample proportion vary from one sample to another. So a different random sample of registered voters might result in a different point estimate of the population proportion, such as, let's say, p hat is going to be equal to 0.53. If the method used in selecting the sample was done appropriately, both point estimate would be a good guess for the population proportion. Due to variety in the sample proportion, we need to report a range or an interval of values, including a measure of the likelihood that the interval includes the unknown population proportion. To understand the idea of this interval, consider the following situation. Suppose you are asked to guess the population of students on your campus who use Facebook. If a survey of 80 students results in 60 students who use Facebook, then the sample proportion is going to be 0.75. From this, you might guess the proportion of all students on your campus who use Facebook is 0.75. Because you did not survey every student on the campus, your estimate may be incorrect. To account for this error, you might adjust your guess by stating the proportion of students on your campus who use Facebook is 0.75, give or take 0.05. We call the 0.05. We call that the margin of error. Mathematically, we write this as 0.75 plus or minus 0.05. If asked how confident you are the proportion is between 0.70 and 0.80, you might report, I'm 80% confident that the proportion of students on my campus who use Facebook is between 0.70 and 0.80. If you want an interval for which your confidence increases, let's say to 90%, What do you think will happen to the interval? More confidence that the interval will capture the unknown population proportion. In our case, the proportion of students on our campus who use Facebook requires that your interval will be increased. Let's say we're going to increase our interval from 0.70, 0.80 to 0.65 to 0.85. In statistics, we construct an interval for a population parameter based upon a guess, along with a level of confidence. The guess is the point of estimate of the population parameter, and the level of confidence plays a role in the width of the interval. This will lead us to the next definition. The next definition is the confidence interval. A confidence interval for a known parameter consists of an interval of numbers based on a point estimate, and the level of confidence represents the expected proportion of intervals that will contain the parameter if a large number of different samples is obtained. The level of confidence denoted 1 minus alpha times 100%. For example, a 95% level of confidence when alpha is equal to 0.05 implies that if 100 different confidence intervals are constructed, each based on a different sample from the same population, we will expect 95% of the intervals to contain the parameter and 5 not to include the parameter. Confidence interval estimates for the population proportion are of the form: we use the point estimate, let's say p hat, plus or minus the margin of error. The margin of error of a confidence interval estimate of a parameter is a measure of how accurate the point of estimate is. The margin of error depends on 3 factors: the level of confidence. As the level of confidence increases, the margin of error also increases, and it depends on the sample size. As the size of the random sample increases, the margin of error decreases, and it depends on the standard deviation of the population. The more spread there is in the population, the wider our interval will be for a given level of confidence. From the sampling distribution of the sample proportion, which as we studied last week, for a simple random sample of size n, the sample distribution of this sample proportion is approximately normal, with a mean is equal to the population proportion and a standard deviation is equal to square root of the population proportion times 1 minus population proportion divided by the sample size, provided that n times p times 1 minus p is greater than or equal to 10 to make sure that the distribution is actually normal. Note that we also require that each trial be independent when sampling from finite populations, and n is less than or equal to 0.05 times the population size. Interpretation of a confidence interval. A 1 minus alpha times 100% confidence interval indicates that 1 minus alpha times 100% of all simple random samples of size n from the population whose parameter is unknown will result in an interval that contains the parameter. Let's construct a confidence interval for a population proportion. Suppose that a simple random sample of size n is taken from a population. A 1 minus alpha times 100% confidence interval for p is given by the following quantities. The lower bound for the interval is going to be the sample proportion minus z of alpha divided by 2 times square root of p hat times 1 minus p hat divided by n. And the upper bound is the sample proportion plus z sub alpha divided by 2 times square root of p hat times 1 minus p hat divided by n. The margin of error, E, which is we're going to use the uppercase E to indicate the margin of error, in a confidence interval for a population proportion is given by z sub alpha divided by 2 times square root of p hat times 1 minus p hat divided by n. Let's look at this example. Example number 2, to construct a confidence interval for a population proportion. In July of 2008, a Colorado University poll asked 1,783 registered voters nationwide whether they favored or opposed the death penalty for persons convicted of murder. 1,123 were in favor. Obtain a 90% confidence interval for the proportion of registered voters nationwide who are in favor of the death penalty for persons convicted of murder. First, we want to obtain a point estimate, which is p hat. P hat is equal to 0.63. We computed this previously, and we want to check whether the distribution is normal or not. So we're going to say n times p hat times 1 minus p hat, and indeed that is greater than 10, so the population is normal. And the sample size is definitely less than 5% of the population, since we're talking only about 1,783 people out of all of the registered voters in the United States. Now we're going to, since we want to construct a 90% confidence interval, that means alpha is going to be equal to 1 minus 90, which is 10%. To illustrate that, I'm going to try to draw it. Here is the normal distribution. And the mean is going to be in the middle, and we know that the mean of the distribution of the sample proportion is equivalent to the population proportion. And I want an interval that is 90%. So I want to be 90% confident. My interval has to be 90%. Now I would like to find the lower bound and the upper bound of my interval. The lower bound is basically p hat minus z sub alpha divided by 2 times square root of p hat times 1 minus p hat divided by the sample size. Similarly, the upper bound is p hat plus z sub alpha divided by 2 square root of p hat times 1 minus p hat divided by n. If I find the lower bound and the upper bound, then that is going to be my interval. Now, how do we find z sub alpha divided by 2? Alpha is the leftover area. How do we find z sub alpha divided by 2? I know that the rest, which is the area in the tail, which represents, in our case, both of them will represent 10%. Each one of them is 5%. So 5% here and 5% here. We're eliminating that. So that means that 5% of this data does not contain the population proportion. To find z sub alpha divided by 2, we can find it using the area to the left of it, which is 5%. To find that, we're going to use Excel. So if you go to Excel, then the area to the left, let me actually draw that here as well. We have this normal distribution. And we want to find this missing z, and we know this area is 0.0545%. To find the z, that means this is a standard normal distribution with mean is equal to 0 and standard deviation is equal to 1. So I can use that value of z is equal to norm dot inverse. Sorry, I'm going to use the function norm dot inverse to find that value. And since I'm talking about the standard one, the mean is going to be 0 and the standard deviation is equal to 1. Or I could just use the S, the standard one, right away. And it's going to ask about the probability. The probability is the area to the left of the number that I want to find. So 0.05 and enter. So that is the negative value, and the positive value is going to be on the other side, and it is going to be similar. So we found out that z sub alpha divided by 2 is 1.645. So on this side, it is negative 1.645, and on this side is going to be 1.645. And we proceed. So the lower bound is basically p hat. We computed p hat in here. And then we're going to say minus, and then z sub alpha divided by 2, which is we found right here, times p hat times 1 minus p hat divided by the sample size is equal to 0.61. So this lower number is going to be 0.61. Similarly, you're going to find the upper number. 0.61 is the lower bound of my confidence interval. And similarly, the upper bound is going to be 0.65. So we're going to say we are 90% confident that the proportion of registered voters who are in favor of the death penalty for those convicted of murder is between 0.61 and 0.65. The sample size needed for a specific margin of error, E, and a level of confidence 1 minus alpha. The sample size formula is given by N is equal to the sample proportion times 1 minus the sample proportion times Z sub alpha divided by E, the margin of error, all squared. The formula uses p hat, which depends on the sample size, the quantity we are trying to determine. Two possible solutions. We're going to use an estimate of p hat based on a pilot study or an earlier study, or we're going to let p hat is equal to 0.5. So because the p hat that we're going to use to estimate the sample size uses the sample size itself, because remember, the formula is equal to p hat is equal to x divided by n, so it depends on n, and we want to compute n. We want to compute the sample size. So we have two solutions. Either we're going to use an estimate of p hat based on a pilot study or an earlier study, or we're going to make p hat is equal to 0.5, which gives the largest possible value of n for a given level of confidence and a given margin of error. Usually we will go with the second option most of the time, but sometimes p hat is provided. So this is the formula to determine the sample size needed for estimating the population proportion P, and notice that p hat is a prior estimate for P, or we're going to use p hat equals to 0.5. If a prior estimate of P is unavailable, the sample size required is 0.25, which is 0.5 times 0.5. If a prior estimate P is unavailable, then the sample size required is N is equal to 0.25 times Z sub alpha divided by 2 divided by the margin of error all squared. Notice here that P hat times 1 times P hat is equal to 0.25 because we assume that P hat is equal to 0.5. Let's look at this example to determine the sample size. A sociologist wanted to determine the percentage of residents of America that only speak English at home. What size sample should be obtained if she wishes her estimate to be within 3 percentage points with 90% confidence, assuming she uses the estimate obtained from a census of the year 2000 supplementary survey of 82.4%. So p hat is given in the question. P hat namely is going to be equal to 0.824. So let's see how we're going to solve that. The margin of error from the question, she wants the estimate to be within 3 percentage points. That means the margin of error is 0.03, and the confidence interval or the confidence level is 90%. That means alpha is 10%, and alpha divided by 2 is 0.05%, and from that we're going to find Z sub alpha divided by 2. So we have the margin of error 0.03, and we have Z sub alpha divided by 2. We previously computed that number. And we have p hat, so n is equal to p hat times 1 minus p hat times Z sub alpha divided by 2 divided by the margin all squared. And the answer is 436. And because we're talking about a sample size, we're always going to round up. So the sample size obtained is going to be 437. So the sociologist must survey 437 randomly selected American residents to get her results within the margin error she specified and with 90% level of confidence. So that is it for this week. I hope that this video was helpful for you, and I will see you in class.